In this video, we shall be solving a question on negative exponential distribution. For more on this topic, you need to subscribe to this channel. We are asked to find the moment generating function for this distribution given, and this distribution is known as the negative exponential distribution. Solution. We should recall that for the moment generating function is equal to the integral ranging from 0 to infinity exponential tx dot f of x, which is multiplication of this. The next thing to do is for we to use this negative binomial and infuse into this function here. So it then means that our moment generating function will be equal to the integral, since it's a continuous case, from 0 to infinity exponential tx multiplied by the whole of this function, because this is f of x. So we have it as 1 all over beta exponential negative x all over beta dx. So this is what we are to solve. The next thing to do is to rearrange this very well. So we have this as from 0 to infinity, we have 1 all over beta exponential negative x b dot exponential tx dx. Is still a moment generating function, is also equal to from 0 to infinity 1 all over beta exponential. We put this together. If we put them together, we have negative x beta plus tx dx. We are not done yet. We'll still find out something is common here. If we watch out, something is common here, and which is x. So we'll bring them out. So we have the integral function 1 all over beta exponential negative x in brackets 1 all over beta. This is positive, it turns to negative, and here we have t dx. So we can still rearrange this, meaning that our moment generating function will be equal to from 0 to infinity 1 all over beta exponential negative x. This will multiply this to give us 1 minus beta t all over beta dx. So the next thing to do is for we to integrate this function. We come over to this side. We come over to this side. If we take the integral of that function, if we take the integral of this function, we'll get this will come over here. We'll get our moment generating function to be equal to the integral from 0 to infinity negative beta all over 1 minus beta t 1 all over beta, sorry, we are already integrating. So negative beta all over 1 minus beta, we are integrating already, exponential x 1 minus beta t all over beta, then infinity to 0. The next thing to do, anywhere we see x, we substitute infinity, and minus anywhere we see x again, we substitute 0 to give us our moment generating function to be negative beta 1 minus beta t 1 all over beta exponential negative infinity 1 minus beta t all over beta negative negative. We also bring this here, beta all over 1 minus beta t 1 all over beta exponential negative 0 multiplied by 1 minus beta t all over beta. So this is what we get. Of course, the whole of this function will give us 0 minus the whole of this is 1, so we get beta all over 1 minus beta multiplied by 1 all over beta, which is this, multiplied by 1. The whole of this, since 0 is multiplying this, so we get 1 here. This is also equal to our moment generating function. So to conclude on that, we come over to this side. To conclude on this, we come over to this side. To find the moment generating function. So the moment generating function this will give us our moment generating function for the negative exponential distribution will now be negative multiplied by negative. We'll get positive. So we have beta all over 1 minus beta multiplied by 1 all over beta and multiplied by 1. So this will cancel this. It then means that, therefore, our moment generating function is equal to 1 all over 1 minus, sorry, this is t, 1 minus beta t. So this is the moment generating function for the exponential distribution. This is how we can obtain the moment generating function for the negative exponential distribution. And the moment generating function will give us 1 all over 1 minus beta t if we follow the process which I have shown. For more on this topic, you need to subscribe to this channel.